In this stoichiometry video, you're going to learn how to convert moles of a product to grams of a reactant. There's also a bonus part of the video that's only a minute extra. That's if you want to learn how to convert from moles to moles as well. When given a problem such as this one, which reads, if you would like to produce 18.9 moles of hydrogen gas, how many grams of aluminum would you need to react in the following reaction? And then it gives you the balanced equation of this reaction down below. The first thing that I would do is set up a table so you can set up your knowns and unknowns. The table consists of grams, molar mass, moles, and what I call the molar expressway. You want to have 3 boxes underneath each element or compound in the balanced equation, and you also want 1 long box for the molar expressway on the bottom. Next, you find out what's your known. It's 18.9 moles of hydrogen gas. That's what it says in the problem. So you go to the moles row and you write in 18.9 moles of hydrogen gas. Notice that I'm in the column of hydrogen gas and I'm in the row of moles, and that's why I put my known right here. If you look in the problem for the unknown, it asks how many grams of aluminum would you need to react. So up here I'm going to put, okay, that's what I don't know. I don't know how many grams of aluminum I need to react in order to produce 18.9 moles of hydrogen gas. In order to solve this problem, we're going to convert moles of hydrogen gas into moles of aluminum, and then the second step is to go from moles of aluminum to grams of aluminum. In order to convert moles of hydrogen gas to moles of aluminum, we use the molar expressway. So what do we write in the molar expressway? Well, you always look at the balanced equation, and what are we dealing with? We're dealing with hydrogen and we're dealing with aluminum. So we're going to look for hydrogen in the balanced equation and aluminum in the balanced equation above. And you can notice that for every 2 moles of aluminum that react, it's going to make 3 moles of hydrogen gas. And that's exactly what we're going to put in the molar expressway. 2 moles of aluminum react in order to make 3 moles of hydrogen gas. So we're going to write that as 2 moles of aluminum equals 3 moles of hydrogen gas. Now you're going to use this mole to mole conversion factor in order to solve for moles of aluminum. So you're given 18.9 moles of hydrogen gas, and if you multiply by this conversion factor, for every 3 moles of hydrogen gas that react or that are produced, you needed to start off with 2 moles of aluminum. Notice that moles of hydrogen gas are on the bottom of the conversion factor because these need to cancel, and you're left with the units moles of aluminum. If you do this problem in your calculator, 18.9 times 2 gives you 37.8, and then you divide that by 3, and that gives you 12.6 moles of aluminum. And that 12.6 you're going to write under the aluminum column in the moles row, so you have 12.6 moles of aluminum. In order to figure out how many grams of aluminum are equal to 12.6 moles of aluminum, you need to find, okay, what's the molar mass of aluminum? In order to do this, you look on the periodic table. And according to the periodic table, 1 mole of aluminum is equal to 26.98 grams of aluminum. You write this in the molar mass box. 1 mole of aluminum is equal to 26.98 grams of aluminum. Next, you use dimensional analysis to go from moles to grams, to convert from moles of aluminum to grams of aluminum. So you have to use this molar mass that you just came up with to solve that. So you start off with 12.6 moles of aluminum, and you multiply by the molar mass. On the bottom you put 1 mole of aluminum, and on the top you put 26.98 grams of aluminum. The reason why we put moles of aluminum on the bottom is because the units have to cancel. Now 12.6 times 26.98 divided by 1 gives you 158.76 grams of aluminum. So if you want to produce 18.9 moles of hydrogen gas, you need 158.76 grams of aluminum to react. The last part to this problem is just checking significant figures. In the problem you start off with 3 significant figures, and during the problem you're dividing and multiplying the whole time. So your final answer should have 3 significant figures, which it doesn't right now. So in order to convert 158.76 into 3 significant figures, you say, okay, these are the 3 most important figures. The 7 will round the 8 up, so your final answer will be 159 grams of aluminum. So just a quick review. In order to get this final answer of 159 grams of aluminum, what we did was we started with our known. We converted moles of hydrogen gas to moles of aluminum. We used the molar expressway to do this. And when you find these numbers on the molar expressway, they come straight from the balanced equation. The next step, the second step, was we converted moles of aluminum to grams of aluminum. We had to use the molar mass of aluminum in order to do that, and that mass came straight from the periodic table for aluminum. So it was a 2-step problem, and it sort of looks like a U, or a little bit of a deformed U. The only thing that you didn't have to do is in this problem you don't have to convert grams to moles like we did in the last video where you had to convert from grams to moles. So there is a section here that you did have to do in the last video, but that's missing in this video because you start with moles and you convert to grams. So it's only 2 steps instead of 3. I promised you a bonus question, and it has nothing to do with this question up here, although we're going to use the same balanced equation. So if you're given this balanced equation, and let's say you start off with 18.9, or that you're going to produce 18.9 moles of hydrogen gas, I want to know how many moles of aluminum sulfate would you also produce if you produced 18.9 moles of hydrogen gas according to the balanced equation above. So this is actually just a 1-step problem. You would convert moles of hydrogen gas to moles of aluminum sulfate using the molar expressway. Well, how do we do that? Well, remember, the molar expressway, you always use the balanced equation. So in the balanced equation, you have 1 mole of aluminum sulfate and you have 3 moles of hydrogen gas. So in the molar expressway, we'll put 1 mole of aluminum sulfate equals 3 moles of hydrogen gas. And then you're going to use the original 18.9 moles of hydrogen gas. Your conversion factor, you'll put the 3 moles of hydrogen gas in the bottom and the 1 mole of aluminum sulfate in the numerator. And you take 18.9 times 1 divided by 3. The moles of hydrogen gas cancel, and you get 6.3 moles of aluminum sulfate. So you'd write that in this box, 6.3 moles of aluminum sulfate. So if you're converting from moles to moles, it's actually very easy. All you need to do is use the balanced equation to convert from moles to moles. It actually should be 6.30 moles of aluminum sulfate, since there's 3 significant digits that we start off with. In the last problem, we converted from moles to moles moles of hydrogen gas to moles of aluminum sulfate. But we could have easily used the moles of aluminum. So if we know that 18.9 moles of hydrogen gas is made and 12.6 moles of aluminum was reacted, you could also, instead of using the 18.9 moles of hydrogen and the molar express way to find the amount of aluminum sulfate, you could use the 12.6 moles of aluminum in order to find out how much aluminum sulfate is produced. You'd use the molar express way, but you'd be going from aluminum to aluminum sulfate. So you look at the balanced equation, you'd say for every 2 moles of aluminum in the balanced equation, I would produce 1 mole of aluminum sulfate. Using dimensional analysis, 12.6 moles of aluminum, that's how much we start off with, and you use the mole ratio, 2 moles of aluminum on the bottom and 1 mole of aluminum sulfate in the numerator. The moles of aluminum cancel. 12.6 times 1 divided by 2 gives you 6.3 moles of aluminum sulfate. That's exactly the same number of moles of aluminum sulfate that we got when we converted 18.9 moles of hydrogen to moles of aluminum sulfate. Sorry, it's 6.30 moles of aluminum sulfate. Either way you go, you're going to get the same answer. So using this box method and dimensional analysis, you can solve pretty much any problem any way. If you want to convert moles of aluminum sulfate to grams of aluminum sulfate, you could find the molar mass of aluminum sulfate and do that. You can go anywhere with this map. You can convert moles of aluminum or grams of aluminum to how many grams of hydrogen sulfate would be produced. You're always going to be using a U method either one way or the other way. Okay, I hope you learned a lot in this video and you do well on your next homework or test.